So we're looking for an antiderivative here, and we're faced with an integral, don't really know what to do with it. You hope a formula works. Doesn't really seem like we have one of those that's going to be useful right away. Try u substitution, thing that seems obvious here. Can you let u equal what's in the denominator? Doesn't really seem like that's going to work. Now in this case, what you might try is you might try a partial fraction decomposition. This is a polynomial over a polynomial. So if this denominator factors, you might be able to break this up into two simpler fractions and have two pretty simple antiderivatives to do as a result. But if you try to factor this denominator, I think you're going to realize that that doesn't work. So when you're in this situation, you have a constant in the numerator and something that's quadratic in the denominator. What you can try to do is you can try to build an integral that's going to allow you to use this antiderivative formula. The antiderivative of 1 over 1 plus u squared with respect to u is going to be the inverse tangent of u plus a constant c. So it's going to take a bit of manipulation and creativity to try and take this starting point and get to the point where we have something that resembles this. But that's going to be what we attempt to do here. Now, the first thing I want to take care of is making this number in the numerator what it needs to be in this numerator, and that's a 1. And we can factor the 4 out in front of the integral. That's not a big deal. You've done that before. We're doing it right here. Now, the issue is you would like to see not something squared plus something else plus 5 in the denominator. You would like to see one thing being squared in that denominator plus some constant that we're eventually going to turn into a 1. So I'm not too worried about this 5 right now. We'll handle that 5. We'll factor out a 5 and turn that into a 1 when the time comes. We need to address this sum. We want to turn this into a perfect square. And so what I'm going to do is I'm going to use the formula for completing the square, which says this. If you have x squared plus bx, and you want to put something on this blank right here that creates one quantity being squared, that creates a perfect square trinomial essentially, what you can always pick is the coefficient of x divided by 2 and then squared. Every time you fill that blank with this value, you're going to be able to turn around and factor your expression as a perfect square where the number in with the x is going to be b over 2. So if we look at this expression right here inside the parentheses, I want to fill this blank with 2 over 2 squared, right? b over 2 squared. So 2 over 2 is 1, 1 squared is 1. Now if I put a plus 1 there, I'm changing the value of what I started with. I can't get away with that. I'm going to have to do something that offsets adding a 1 in this denominator. And what offsets adding a 1? Well, subtracting 1. And then I do still have my differential dx here. So what we can go ahead and do on this next line is we can say this quantity we just completed the square within. We're going to be able to rewrite that as one quantity being squared. And if you think about factoring this, you're going to realize that it factors to x plus 1 times x plus 1, or x plus 1 quantity squared. You can either use the other side of this formula to factor it or factor it by hand. And then you have a plus 5 and a minus 1. Those are like terms that will combine to a 4. So now we do have one thing being squared within that denominator. That's good. That's what we wanted. But now the thing that we don't like is we don't like the fact that the constant term in that denominator is a plus 4. We want it to be a positive 1 like this formula says. So to turn that plus 4 into a plus 1, what we're going to have to do is we're going to have to factor a 4 out of the denominator. So I'm factoring a 4 out of the denominator. When I do that, it's going to join the 4 that was already outside the integral, and they're going to cancel. So that's kind of nice. Those constants go away. If I factor a 4 out of 4, I'm dividing by 4, and I get a value of 1. That's why we did the factoring out of 4. This is going to be a little bit goofy to try and factor a 4 out of. But remember, when you factor something out of a term, you have to divide that term by what's being removed from it, by what's being factored out of it. So that piece does get a little ugly. And now we have kind of messed stuff up for ourselves, at least momentarily, because we wanted this right here to be one thing squared. Right now, it's something squared divided by 4. So it's easy to fix that issue. You want to rewrite that as one thing squared. Well, how do you write 4? How do you rewrite 4 as something being squared? Well, it would be 2 squared, right? So take that 4, group it in the quantity that's being squared, and now you have one thing being squared in that position. You do still have a plus 1. You're doing this integral with respect to x. Now you don't have this exactly yet, But if you let u equal what's inside this quantity, x plus 1 over 2, you do have this exactly. Now, the only other thing that we have to worry about is we have to worry about what happens if we do this substitution. This is not going to be an issue. The reason why this works is because this quantity is linear. When you let u equal something that's linear, you might pick up a new constant. We will see that that's what happens here, but you won't have to rely on any other cancellation occurring within your integral. So we're going to rewrite this integral as 1 over u squared plus 1. What are we going to put in place of dx? Well, if you think about how you can rewrite u, you have x being divided by 2, so that can be written as 1/2 x, and then plus 1 divided by 2, so plus 1/2. So what's the derivative of u with respect to x going to turn into? Well, the derivative of u with respect to x, the derivative of 1/2 x is 1/2. The derivative of 1/2 is 0. What does dx equal? What are you going to replace dx with? So I'm going to multiply by this 2, so I'm going to have 2 du. I'm going to multiply by the dx. This is what's going in place of the dx. And now we're ready to go ahead and take our antiderivative. The 2 can factor out in front of the integral. And then what's the antiderivative of 1 over u squared plus 1? Well, all video long so far, we can't see it at the top of the screen right now, but I've been referring to that formula that gives you a result of inverse tangent. So if we go back up and show it real fast, the integral of 1 over 1 plus u squared with respect to u is going to be the inverse tangent of u plus a constant c. So we're finally to the point where we apply that. We do have to tack on our plus c. Last thing to do would be to back substitute, and we want to toss something that involves x back in place of u. Well, what's u equal? X plus 1 over 2. So 2 inverse tangent of x plus 1 over 2 plus c is the antiderivative of what we started with.